Hi guys, so in this video we're going to be going over some of the trigonometric graphs, and later on we'll go over transformations in another video. But we've learned three different functions: sine x, cos x, and tan x, and we have to learn how to also graph them on a coordinate plane. So we're going to start with graphing it in degrees, and then I'll move on to explain what radians are for a little bit. So we know that there's sine x, cos x, and tan x. So I'm going to do those in different colors. And basically, when you put in a value of x, it'll give you a corresponding y value. So you can think of this as y equals. So y equals sine x, y equals cos x, and y equals tan x. So they're functions. So we'll start with sine x. So this refers back to the unit circle video. So if you haven't watched that already, I recommend you go watch it. So y equals sine x. When you start with sine 0, we know that sine 0 based on our unit circle is 0. Whereas 90... I'm just going to go through this quickly. Sine 90 is 1. Then 180 is back to 0. Then 270 is negative 1. So I'm just going through the critical values of sine x. And then 360 is back to 0. And that's one cycle. We also know other ones like sine 45, which we know is root 2 over 2. So 45 would be about here. And root 2 over 2 is approximately, let me just put that in to my calculator just to get a general value. It's about 0.7. So if we move up, so this is 0.2, 0.4, 0.6, 0.7 was about here. So it'll look a bit like that. So what we can see from this curve, it's a bit like this. It's curving like, oops, let me draw that second part again. I'm not very good at drawing these, but that's about how sine x looks. If you join out the points, it's a curve like that. So you should know the general shape, so it's easier to connect the dots. Then we have cosine of x. And if we do the same thing, so cos of 0 is 1. At 90, it's 0. 180, it's negative 1. 270, it's 0. And then 360, it's back to 1. So this is one full cycle of cosine of x. We know at 45 it's at the same place as sine x, so we can draw it a bit like, oops. Oh, let me draw that last part again. I'm sure you can draw it better than I did, but that is generally the shape. And our last one, which we need to know, is tan of x. So tan of x we know is sine over cos. And with that said, we know that at 0, sine over cos is, well, sine is 0, cos is 1, so tan has to be 0. And then at 45, sine and cos are equal, which means you can think of it as a bit like sine over sine or cos over cos, because we can let sine x be cos x or vice versa. And that just equals 1, because when you divide anything by itself, you get 1. So tan 45, we can put at 1. Now tan 90 is interesting because sine is 1, but cosine is 0. And cosine is in the denominator, which means we have an undefined value. So this is an asymptote for tan x at 90. Similarly, when cos is 0 again, there will be another asymptote since this is the denominator, and that's when x is 270 degrees. So we can draw them over here. And what we can also do is add in any of the other critical points. So 180 degrees for tangent is, we have sine as 0, cos is 1, so this is again 0. And we know that 135 is basically the same as tan 45, except in the second quadrant, so it's going to be negative. So this will be negative 1 at tan 135, which is about here. And then at tan 225, which is basically the same as tan 45 because they're in the positive quadrants of tan. If you haven't watched the unit circle video, this won't make sense, so make sure to watch it. That's around there. And then similarly with tan 315, 315 is the same as the negative of tan 45 since this is in the fourth quadrant. So 315 is around here, so it would be negative 1. So it looks something like that. And if we join the dots up, well, we know that, well, I'm going to let you know now that tan has a general shape of like that. It's about a really long squiggle. So over here, we can look at the middle portion since that's where all the points of tan come in between two asymptotes. We can connect them like this. That's a really bad drawing. Didn't even really go through one point, but you get the idea. You would have to draw this on one continuous stroke in the exam, but I'm just showing you a rough one. So that's what it would look like. Knowing it's this long, we know that this part over here does not fit the whole tan curve in one page. So we can start to draw it like this. Fits only the last portion really fully. And then similarly, in this right portion over here, it only fits the first portion fully. So you can show it going like that, tending off that way. So over here, we can kind of, well, we can also see that it goes through 360. So be more like this. So this is generally how the curves look between 0 and 360 degrees. You will need to know generally how to draw these, but don't worry, if you can't remember all these different steps, that's not a problem. You have your green calculator. So what's so good about your green calculator is that it actually allows you to get all the values of sine, cos, and tan. After that, it's just connecting the dots. So what you should do is click table, then you'll get y equals, and you have to fill in the function. So for example, let's say I wanted to know it for tan x, because tan x is so complicated. You just tap the tan button, then x, close bracket, enter. Now you've got start, step, and auto or ask x. So start, we can say we're starting, so it depends on your, it depends on the region which you're doing it, the domain. So the domain is basically the range of x, values that are shown of the function. So technically, these trig graphs keep repeating themselves. So for example, sine would just keep going like this, then cosine would just keep going like this, and then tangent would keep going like this. Really rough scratches, but you get the idea. It keeps going on. Which means that the domain is necessary to ensure the function exists in one specific region. Remember how we were doing the trig equations and the solutions were restricted to a domain? Because technically there are infinite solutions, but we have to restrict the domain to ensure that there are only a specific number of them. So in this case, I've done it from 0 to 360, as you can see, because that's one full cycle. For tangents, actually 180 degrees as the period, because it goes from 90 to 270. That's the region in between the two asymptotes. But for the other two functions, the period is basically the amount is the how many times it goes through one cycle in between 360 degrees is 1, because 0 to 360 is the period. So if that didn't make any sense, basically what that means is that in one cycle of sine is 360 degrees, for cosine it's 360 degrees, and for tangent it's 180 degrees. All right, so now going back to the calculator, so we start at 0 degrees for our period, in this case, or domain. Then we step by 45, because 45 makes it really easy to get really specific values of x while not getting really weird decimals. So oftentimes if you do something like, 15 degrees or 10 degrees, you're going to get, for example, tan 20 is not going to be a pretty number. It's going to be a very ugly decimal. That's why it's important to make sure your step is in a way that you get values that are easy to plot. So for tan, 45 is the smallest decision since you don't get any decimals that way. Then you press auto, you leave it to auto, and then you press enter, go to OK, and press enter again. And then it plots all the x and y values for you. It doesn't give you the graph, but it gives you all the values. For example, tan 0 is 0, tan 45 is 1, tan 90 it'll say error, which means that it's undefined in this case because you're dividing by 0. Tan 135 is negative 1, 180 is 0, 225 is 1, 270 is back to error, etc. And these are all the values we just plotted. So it just makes it really easy. You can just draw x's like I have at each of these values that the calculator gives you and connect the dots. What's really helpful is that this will get you through any exam. So in the CIM exam, you could just graph it on your GEC because that can actually show you the graph. But then for AdMaths, they might ask you to graph these kind of things and you need to be able to do it. But you have your green calculator at all times. So I suggest using the table function to do so. So that's it for this video. Before I finish this video, let's go into radians. So radians are basically another way of expressing angles. And in many cases, you will need to use radians. I'll cover a video on where radians are more important than degrees. But basically, the general thing to remember is that pi is equal to 180 degrees. That's how it works in radians. So for example, this 0 to 360 range would be referred to as 0 to 2 pi, because 2 times pi, where pi is 180, is 360 degrees. So using this conversion, you can kind of convert from radians to degrees and degrees to radians pretty easily. So we can say that pi over 2 is equal to 90 degrees, pi over 4 is equal to 45 degrees, and so on. So that's just the general way you would do it. And let's say you had 270 degrees. The way you would convert to radians is divide by 180 times pi. So if x was an angle in degrees, to get the angle in radians, you would do x over 180 times pi. And the other way around is if you want to convert from radians to degrees. You would just divide by pi and times by 180. So I hope that was a quick intro into radians, just before we go into future videos, because radians are very important at add math level. At CIM level, you don't need to know radians, so don't worry about it. But for add maths, you will. And I'll make another video where you will need to use radians in very specific scenarios, otherwise you won't be able to perform the same calculations. So anyway, a little bit of a ramble from me, but thank you so much for watching the video. I hope it was helpful. If you have any questions, because this is a slightly confusing topic, let me know, and see you in the next one.